again. So I draw a circle. I need to get to an angle of 5 pi thirds or 5/3 pi, but I like to count 6 because they're easier. So it means I've got to go 10/6. So I'm looking for 10/6 of pi. Well, if you divide the top half of the circle into 6 even pieces, you can see that right here is 6/6 pi, which makes sense because half of the rotation is pi. So then it'd be 7, 8, 9, 10 is where I'm looking. So that's the angle. The sign is always the y-coordinate. Y-coordinate is always the distance down from the origin. So that distance down is the long distance. That's why I know it's root 3/2, because I went down, I know it's negative. Need more? Is that okay? Good. 2 for Rachel. Video. Awesome. Okay, I'm going to pass a clipboard. On the clipboard, you write down your score for quiz A and quiz B. And I was helping someone just a minute ago in period 1, and I mentioned to them that they're still struggling a little bit on this, but they came and talked to me trying to get it cleared up. I'm not really that interested in your actual quiz scores. I'm interested in your progress. So if something like this is causing you trouble, and you come talk to me, and I try to help you, and then you give it another shot, and you're still having trouble, you come talk to me, as long as it eventually gets fixed, and you eventually demonstrate to me that you really have it, like you're not going to have trouble with this any longer, we can always go back and say, oh no, you've shown that you now understand it. We'll make some modifications to those earlier scores, because it's your final outcome that I care about, not what happens along the way. So write down both scores and just pass it around. Okay, also, I forgot to mention this on the first day. I did mention that I feel like this is a professional environment. You're professionals, you know how to act like professionals. So, at the risk of criticizing another class, I don't really believe in potty passes or extra credit if you can somehow hold it and wait until the class break, and I just don't. So if you need to leave, you just leave. Okay. I do need to keep track to make sure only one person is out of the room at a time. So there's a hall pass just sitting in the tray. Grant will grab it and demonstrate for you. Very simple. There you go. Nice thing. Put it back in the tray. Just quietly grab it and walk out. I won't even ask anything. So calculus just doesn't have a problem because people learn very quickly that the goal is not to miss class. The goal is to be in class. So, questions? Cool. Right. Last time we were right here talking about this picture. And I told you that I need you to think of this as being an open circle. So we're going to kind of pick up exactly where we left off last time. This is an open circle. We talked about how to read the graph. Now that you know how to properly read the graph, I can introduce a new mathematical operation. The new operation is called finding a limit. So long ago, you had a teacher introduce you to a new mathematical operation called multiplication, and you learned what multiplication meant, right? And you've had that happen over and over again. Well, today is no different. It's just a new operation called a limit. So, you'll want to write down the notation so you can get it memorized. So write this on your paper. The limit as x approaches 0 of f of x. So this is the notation. The limit, they just abbreviate limit, they don't ever spell it out. So the limit as x approaches 0 of f of x. I'm just watching your pencil to make sure I don't go faster than you can write. So. Perfect. Okay. Here's what it means. You've memorized that Thank you. we memorize that a function is a list of inputs and outputs. Okay? So here we are. We have a function. It's depicted graphically, but it's nothing more than a picture of an infinite number of dots, where every dot is an input-output pair. Okay, when you read this, you think inputs and outputs. They want you to be thinking of the input value getting really, really close to 0, and then you're supposed to figure out when that happens, what does the output value get close to? So I'll say it one more time and watch where I'm pointing. X approaching 0 means the input's getting close to 0. F of x means you're supposed to figure out what does f of x get close to. We need the output value. And the key is close to, not exactly equal to. It says x approaches 0. It doesn't say x equals 0. So you cannot be thinking x equals 0 because it doesn't. X is infinitely close to 0. Question? Okay. Next thought should be this. Well, there are two ways to get infinitely close to the number 0. I can either pick a number that's slightly less, like really, really close to 0, but just a little bit negative. Or I can pick a number that's a little bit more, close to 0, but slightly positive. So you have to memorize that there are two ways to get close to 0. They will not give you any sort of clue on the test, the AP test, as to that fact, that you have to think of this as, oh, there's two ways to get close. So your brain automatically thinks, I need to do this. If they're asking me for this, I need to go find this one. I need to figure out what's happening when the x value is getting really close to 0 from the left. Meaning it's really close to 0, but it's just a little bit negative. That's where you have to start thinking about it. But you can't forget that you must also think about the fact that x could get close to 0 from the right. So every time you see an overall limit, you have to think of both what's called the left-hand limit and the right-hand limit. They will not prompt you to do this. In the homework tonight, I kind of prompt you because it's your first shot at it. They won't. They'll expect you to know that when you're answering this, you've got to think of these two. Any questions coming to mind from anyone? Perfect. So let's talk about the green one for a minute. Actually, related to that is something you've done before. We did this last time as well. There's this idea. What is f of 0? Well, like on the quiz last time, f of 0 means the input value is 0. F of 0 means output value. So I look up at this graph. We put in some scale here. And raise your hand if you know what I should write here. We did this last time, just kind of rechecking. I want everyone to participate. Even if you just kind of like, I'm not really sure, raise your hand anyway. If you're raising your hand, at least I know you're with me and you're thinking. You're not just kind of passively trying to absorb. So what's f of 0? What's f of 0? Let's go, Kate.
Can you put 0 with a little negative step in the bottom one?
So if you're looking here, 2 points for Kate. Misunderstanding, but no big deal. You're looking in the wrong place. When it says f of 0, what I want to do is I go along the x-axis until I find exactly x equals 0. So that's exactly here. And then I look along this line that I'm about to draw. And I look along this line and I try to identify, is there a dot plotted somewhere along this line, which is interesting. Didn't draw, I don't know what. Okay, anyway, I look along that purple line for a dot. Wherever the dot is located, that's the value or the y-coordinate of the function when the x-coordinate is 0. So let's give it a second try. 2 points for Caden for giving it a good shot. Raise your hand again if you know what I should write here. And Caden can raise his hand again and get more points. It's fine. Again, right or wrong doesn't matter. It's the participation that's important. You're thinking with me. So what do I write here? Let's go to Tessa.
1.
So Tessa says 1. She went along this line. She finds this dot right here. She keeps looking, And this is an open circle, so there's no dot there. So the only place there's a dot is at a y-coordinate of 1, so perfect. When the input value is 0, the output value is 1. So how many had it? Show me your hands. So 2 and then 3 for Tessa for being the voice. What?
Would you not put -2 plus?
Good comment. No. The dot you're looking at is right here, I believe. Are you looking right here?
Oh. Okay, so that's a different.
Yeah, it's a good comment though. Hey, sorry I didn't mean to interrupt you. Say it again.
Maybe 0, negative. Okay.
Much better. 2 for Maya for a good question. What Maya said was she was focused here on the green dot, and then she caught her mistake, her misunderstanding, which was, oh no, wait a minute. That green dot does not have an x-coordinate of 0. So I don't want to look there. That green dot has an x-coordinate of just slightly negative of 0. And then the y-coordinate would be slightly positive of -2. So those are the x-y coordinates of the green dot. Relevant, but not for this. Perfect. That makes sense? 2 for Maya. Anybody else? Oh, please.
I'm just confused because like the output is like the x value, but 1 is the x value.
So there's something.
I mean the y value.
You're good. So say it again.
So if f of x is like the y value, the output, but 1 is also x, so f of 0 equals 1. How does that make sense? Because
You have a really good question. Mark down 3, but I've got to kind of sort it out. So it's not your fault, it's my fault, okay? So stay with me.
Okay.
So say it again. It's really good, it really is.
so f of x is the y value.
Pause right there, let's focus on that for a second. So when you see this symbol, let me add just a little bit to that. Sometimes when you are working a math problem and they refer to f of x, in some contexts, they'll be referring to the xy list. Like they'll think of the whole function, they'll say this is f of x, right? And they'll be talking about both the x and y kind of simultaneously. But you're correct, Mikkel,
Yeah.
that the symbol f of x also refers to just the output values. That's what you were saying, right?
Yeah.
Keep talking, you're doing great.
And so I don't get why f of 0 equals 1. I get it's on the 0, like it's on y equals 0, like the line, but
So you're saying this line is y equals 0?
well, that's x equals 0, which is just confusing me even more now.
You're okay. You're doing just great. We just got to keep going and we'll get it to click. So this is the line x equals 0 for sure, because that's the line where every x coordinate is equal to 0.
Yeah.
And so what's the xy coordinate of that purple dot?
It'd be 1, 0.
So
I
the
mean,
input
0,
value is
1.
1. Oh, yeah, we got it
Yeah,
backwards
0,
there.
1.
There you go. So when the input value is 0, the output value is 1. When x is 0, y is 1.
Okay.
Is it
Okay,
clicking
that
now?
makes sense. Yeah.
Is it okay now?
Yeah.
No worries. It's easy to get them turned around. The reason I gave you 3 is put down 4 actually. Seriously, everybody, eyes, look. What you just did is perfect for this class. Like something didn't feel right, and it took a minute to kind of talk through it, but now I'm hoping it feels
Yeah.
perfect. That's what you have to do. If you let things like that slide, you just get more and more mixed up. Because you can't just copy what I'm doing. You have to make sense of what I'm doing. It's perfect. Yeah, oh, please.
For like f of 0, can there be more than one point?
Gotcha. So what Hayden's saying, 2 points for that. This line is x equals 0. Is it possible to come along this line and find more than one dot on that line, correct?
Yeah.
It is possible. If that happens, what you have is what's known as a relation instead of a function. Not super common, but it does crop up. That's why in this problem I said, let's only find one dot, so I made this an open circle. But it is possible, for sure. Same question.
Yeah.
Anybody else? Perfect. Oh, please.
Sorry, I don't know. I just
No.
thought, so kind of like what Kel was talking about. So f of x is like y. So okay, so the f of 0 equals 1, right? Like if I were just to look at that, it would say like y equals 1. But like if f of x is a y and 1 is like a y, is it like is the x like in the y, but the y is the full thing. Does that make sense? So like, so you know how equations kind of go like if you have x on this side, then y is on that side. But if you have like y on this side, then x is on that side. That looks like it's both y's, but the x is like in one of the y's.
Yeah, outstanding.
Right? Does that make sense?
Yeah, well, kind of. Mark down 4.
Does anybody know what I'm talking about?
Brennan. Mark down 4.
Normally you would like do the opposite of what like is on the other side.
I actually think I know exactly what you're saying, but I have to say it back to you to see if you and I are thinking the same. Is that fair?
Yeah.
So that's what I meant when I said I think. It had nothing to do with you.
Yeah.
I'm thinking, okay, do I get it? I'm not sure if I get it. That's my fault, not yours. But I do want others to make sense of what you said. It's really important. Like everyone in the room, the symbols are crucial. If you can't keep track of the symbols, you're going to be mixed up all year long. And you'll get super frustrated. So when I write the symbol f of x, I typically mean one of two things. I either mean a list of xy pairs, both x's and y's, like I think of it holistically as the whole thing, or I'm just referring to the y values, just the outputs. You with me there? Awesome. Now, you're right, we'll get formulas for functions that'll say something like this. I'll just pick an easy one. Okay with that? Okay, that's telling you that to compute the value of f of x, the y values, you can use this formula. You can plug in something for x, square it, add 7, you get the y value. Totally good there? Equal means they're the same thing. So this right here is a symbol for every y value in the function. It's kind of a complicated symbol, but it's still a symbol for any y value. Just like this is a symbol for any y value. That's why we say they're equivalent, if that makes any sense. Now sometimes they'll say, instead of f of x, they'll write y equals. That's what you were saying a second ago, right? So they'll go like this. Good there. Well, that means this is a symbol for every y value, because it's y equal. That's what you were heading towards, though. Kind of.
Well, no, yeah. So is it just like you have to kind of change your thinking? Like if x is on that side, the other side has to be y. Like you don't have to think like that.
Oh, let's talk about that for a second.
Like, yeah, because like f of x, like in my head is like y, and then the 1 was like on the y. You know what I mean? So it's like, where was the x? The x was like in one of the y's.
Let me say it back to you. I think what you're mixing up is that when you see it in this context, you think of this as the y. And you're thinking, oh, this side is where the x belongs.
Yeah.
That's a mistake, but that's okay. Mistakes don't matter.
Because like normally I'm used to that because like of that.
Uh-huh.
It's like they're each on
Yeah,
the
you're
other side.
thinking y goes on this side, x goes on this side. Okay, all eyes on me, everybody. No, we found something that's really crucial to fix. It's perfect, Brendan. The sides don't matter at all. You just kind of picked up that as a habit to think y is on this side, x is on this side. No, that's irrelevant. That doesn't matter at all. It's all about what equal means. So in this context, like in this statement, what I boxed is not x at all. This is y. This is how you find the output values. This symbol is how you find outputs. So this is a symbol for the output of the function. That's a symbol, and this is a symbol. So everything that's boxed is a symbol for the output of the function. I've not boxed any input symbols because the left and right don't matter at all. Stay with me for a minute. Cass, please.
But you would be able to find x by minusing 7 square root.
Right. So I can rearrange. That's what we talked about on the first day, how I said, or second day, I guess, how I said that you can use the formula to find inputs or you can use the formula to find outputs. So as Cass is saying, mark down 2, Cass, I can rearrange this and say, let's see, y minus 7 is equal to x squared. Therefore, the square root, plus or minus, of y minus 7 would have to equal x. So the sides don't matter at all. It's about what the equal sign is telling you. So now, what I have circled right here, that's a symbol for x.
But it's y in there.
But I'm using y to find that value of x. You said that really well.
Yeah.
So this symbol represents x. It represents an input. And the way I find that input is I plug in the output to find the input. Did that help a little? So I'm guessing, and if I'm not helping, I apologize.
No, it makes sense. I mean, I don't even know what I'm asking. I just guess I'm saying, but.
Well,
No, I get it.
Okay, so you're feeling better, right?
Yeah.
Yes, like when you look at this.
Like you're using X to find Y. Because
Exactly. Yeah. So like when I look at this, I don't think, oh, the Y is on the left, the X is on the right. I'm like, no, this says that the output, when the input is 0, is 1. So this is an output value, but I'm using a specific input to find a specific output. So they're both outputs, just different symbols for the same output. You did a great job. You really did. Everyone, do that. Like, you feel uncomfortable? You don't have to have a question. You just have to be willing to talk about it until it feels better. And if I mess up and don't help, blame me. I'm serious. Don't blame yourself. Look at me. You're perfectly allowed in this room, just be polite about it, to like, if I explain something and I say, did that make sense? You can look at me and go, nope. And it won't hurt my feelings, okay? Just tell me, it doesn't make sense, and we'll keep talking. Other comments here? Other comments here? Perfect, so go back to this one. So we found that f of 0 is 1. That means we're looking right there. So back to this idea of a limit. So it's really almost exactly the same thing. This is telling you, look at our function, identify exactly where the input value is 0, and tell me what's the output value at that for that input value. And that output value is exactly 1. This means look on the graph where the input is not quite 0. It's just slightly negative of 0. So what your brain should be doing is this. I go along the x-axis until I find an x-coordinate that is slightly negative of 0. So now my eye is drawn along this line. Because this is the line where every x-coordinate is going to be slightly less than 0. And I want to know what's the output getting really, 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 really close to when the input is really, 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 really close to 0, but just slightly negative. So raise your hand if you know what I should write here. Everybody. What should be written here? The way you read this statement is you say, begin with the function f. I know the input value is going to be just barely negative of 0. Please tell me what the output value is going to be. That's what f is representing in this sentence. The output value. So this is an output value. We're going to write down an output. Weston?
Negative to negative, but positive, yeah.
So you're thinking of this, right? Stay with me, stay with me. So Weston's in the right place. He's coming along this line. He says no dots, no dots. Okay, there's a dot. That dot has an x-coordinate that is infinitesimally close to 0, but slightly negative. The y-coordinate of that dot is just almost negative 2, but a little bit positive. The only thing you do different is you don't ever put a plus or minus there. Because limit means what are you infinitesimally close to? We're not really at negative 2, but we are infinitesimally close to a y value of negative 2. 1 second, Avery. One nice thing for this class, we don't do deep limit problems. So every answer to a limit question will always be something straightforward. Negative 2, 5, 0, 1. You'll never have an answer like that. Avery, please.
So then why is it an equal sign? Like, wouldn't it just be another arrow?
Gotcha. That's just what they chose to say that the notation means. So your thinking is perfect. As x gets close to 0 minus, it's like you can think of it this way. As x gets close to 0 minus, f of x absolutely is getting really, really close to negative 2. You could write it like that. Or it's getting close from the positive side. The thinking is perfect. The word limit means tell me the whole easy to write down number that we're getting close to. So we just write negative 2. 2 points. Anybody else? Solid. So raise your hand if you know what I should write here. The meaning is the same, except that now we're getting close to 0 from the positive side. Show me your hand. Let's go Hadley. So Hadley's looking here. She says 0 plus means the x-coordinate's a little more than 0. Her eye is drawn here, correct, Hadley? Perfect. She says in her brain, okay, that's an x-coordinate of a little more than 0. The y-coordinate's slightly more than 1, which means the limit, as x gets infinitesimally close to 0 from the positive side, the y value is getting infinitesimally close to 1. It's perfect. Somebody had it? Show me your hand. 2 points. Question. Oh, please.
Okay, so when they give you a question like this, write the next like the 0 minus and the 0 plus. So that's exactly what you answered.
How do I say this? You don't have, I gotta be honest, you don't have to write this.
Okay.
Now, I may, in some homework, insist that you write it just to help you get the idea to make sure you're getting it. But I'm being honest with you, on the AP test, it's not required. Unless they specifically say something like show. If they're just asking, you just mentally do it.
Okay, so then how would you like write that answer then?
Oh, stay with me for a second. If this doesn't answer it, keep talking. So where we started this discussion was, I proposed that you may encounter a question on the AP test that says, hey, find this limit. Oops, come on, 1 second. So we're like right here. We're thinking of this as being an AP question. And they give you this graph. And what I said was, I can't answer this until I've answered this. So I either write it down or I mentally think of it. Once I found the answer to this is called the left-hand limit. This is called the right-hand limit. It comes from the fact that 0 negative is on the left side of 0. 0 positive is on the right side of 0. So once I have these two, I look at them and I make the following conclusion. Well, when I get close to 0 from the left, the y-coordinate's getting really close to -2. When I get close to 0 from the right, the y-coordinate's getting really close to +1. So in general, I don't have any clue as to what's happening when I get close to 0, because 2 different things are happening. So the word they'll use is non-existent. That's how you answer the question.
Okay.
I don't know if that helped you, Maddie.
So that makes sense.
Okay.
Thank you.
You're welcome. 2 points. Anybody else? Oh, please. Yeah.
Wait, so just on the same thing. So if you had one that had two like that, like 2 different numbers, you'd write non-existent. What if it was just the other? Would you just write just a single number?
Perfect. So it's always one of 2 cases. If you're looking for the overall limit and the left and right do not match, the overall limit doesn't exist. If you're looking for the overall limit and the left and right do match, that's the value of the limit.
Okay.
Because then you can conclude that, oh, it doesn't matter how I get close to x equals 0, the number is the same. So overall, I can write that out.
Perfect.
2 points. Allison?
On the like AP test, does it matter if, I mean, do they ever ask like the question like close to 0, like negative or positive?
Oh, gotcha. Yes. So we started this discussion, too, for Allison, by saying, how do I find this limit? I'm telling you, you must memorize that you cannot find the overall limit unless you find the left and right first. There's just no other way to do it. But they will test your knowledge of what left and right mean by sometimes just asking you one of them without asking for the other. So, in the homework, I kind of guide you through it since it's your first shot at it. So I usually ask all 3, but not always. On the AP test, they just kind of ask something. You don't know what they're going to ask. So, yeah. Perfect. Awesome. Okay, next thing. You need to memorize another idea here. Okay, so that's the idea of looking at a graph and identifying the value of the limit, left, right, and overall, as well as the value of the function. We study limits in part because you are expected to understand for the AP test the meaning of this word. And I would write this word down because you will be tested on it. So you want to make sure you recognize its meaning. Discontinuity. They will have AP questions on occasion where they test your knowledge of 3 different types of discontinuities. So you need to memorize these 3. First one is, computer just is so annoying. Okay, the first one is known as a removable discontinuity. The second one is a jump discontinuity. And the third one is a vertical asymptote discontinuity. So get those memorized. You may have heard another teacher refer to this as a whole. That's what I used to call it as well, but the AP test stopped using that language, so I'm going to go with this to get you better prepared for the AP test. So, removable discontinuities. Questions? Awesome. What we're looking at here is a jump discontinuity. The definition is very simple. Jump discontinuity is caused when the left and right limits don't match. So jump discontinuity occurs whenever the left and right limits don't match. And we'll kind of address the other ones as we hit them. So this one has a jump discontinuity. You can see it, it's graphical, it's easy to see because the left and right limits don't match. The common sense definition for whether or not a function is called continuous is, can you draw a picture of the function, meaning can you draw the graph without lifting your pen or your pencil? So if I were trying to draw this graph, and remember the graph's an infinite number of dots, so as I'm drawing all these dots, suddenly I have to stop, pick up my pencil, jump up here and continue drawing. So because I had to lift my pencil, this function is not continuous. That's the common sense idea. So, question. I'm just kind of watching your pens, make sure you don't go too fast. Cool, let's look at another one. So let's go here. Okay, so let's start by finding, so this time I just want to see the whole room. So this one you can answer on your hand. This means 0, by the way. Actually, let's do this. So this is 0. 1, 2, 3, 4. Sorry, I don't know ASL. But this is 0. 1, 2, 3, 4, 5. And if it's non-existent, do this. So show me what this is. F of B. Show me on your hand. F of B. F of B. Good question. So let's see. F of B. Just checking everybody. And right or wrong doesn't matter. What's important is that you're with me trying. Make a mistake, no big deal. So I've actually I've got this answer, I've got this answer, I've got this answer. So here's what I would do. F of B is telling me the x-coordinate is exactly B. So I look along the x-axis until I find an x-coordinate that is exactly B. I then go down that line looking for a dot. I find a dot. That's a pretty good line. I'm pretty happy. Celebrate things, you know, small accomplishments and stuff. I'm really happy with that. That's really straight, is it not? A little bit. It's not bad. Okay. All right. Sorry, I got distracted. So I find the only dot is right there. So that's telling me, let's see, that x-coordinate is B. That y-coordinate is 1. It's exactly back to what Brennan was asking about. 2 more points for Brennan for such a good question earlier. This is a symbol meaning the output value when the input is B. And sure enough, the output is 1. So, 2 points for just trying on that one. I didn't care if you're right or wrong, so as long as you tried. Questions? So anyone who missed it need me to clarify more?
Yeah, could you, just why isn't it non-existent, because there's a hole at 2?
Gotcha.
So where does the 1 come from?
So the way you read the graph is you come over to B, you get there, right? And then you come along the line that's equal to wherever. So all along this line, X has a value of B. I totally ignore that because remember the open circle means nothing's there. There isn't a dot. But there's not a dot here either. There's not one here either. So I'm ignoring all of that. I'm just looking for a dot. I finally find one here. So because there is a dot located when X is equal to B, that means that the function, if this were f of X, that means the functions list would absolutely have X equal B included in the list, and the Y value would be 1.
Okay.
So far, so good. Let's do one thing that's related. I think it might help. 2 points for Rachel. Please show me on your hand, what do I write here? So show me what I should write here. If you're doing this, give yourself 2 points. Well done. So the difference, Rachel, is there was an open circle here, there's an open circle here. But as I go along this line, I don't find a dot anywhere. So there is no value defined. So this one's undefined. Does that help?
Yeah.
Does that clear up your question? 2 more. Anybody else? Please. Avery.
So should you be thinking of like the 2 different segments as like the same function, or is it like, I don't know, because you think about them separately most of the time, I feel like.
Like the segment here and the segment here, that sort of thing. I'm going to guess what you're remembering. If I'm wrong, you keep talking to me. This really, to me, is one function, but it is made up of different segments. So it's really a piecewise function. If you were to write a formula for it, you'd see more than one formula. So it's like one function made up of other functions. Maybe that's what you're thinking. I'm not sure, but for our purposes, we'll think of it as one function.
Okay. So why isn't it like just like different functions? Like what's the purpose of combining?
Oh, it really doesn't matter. It's just a matter of which way we want to think about it. Like it's totally fine if you want to think of it as separate ones or one. In this particular question, the AP writer would want you thinking of it as a single function. It doesn't have to be. That's just a matter of context. Like you can choose to think of it either way, would be fine. Please, Alice.
So for the f of b it equals 1, but if we were to find the limit, it would be undefined because there's 13, right?
So let's do that. So you're just one step ahead. I want to make sure everybody's... No. You're doing perfect. I just want to make sure everybody's with us. So here's what Allison is doing. 2 for Allison, 2 for Avery. She said, okay, let's do this now. The limit as x approaches b. And to do that, we've got to go find the limit as x approaches b from the left. So we'll do this as a class to make sure we're all together. So please show me on your hand, what should I write here? Go. So what should I write for this one? Show me with your fingers, or your fist, or your zero, or whatever. So the limit of this function, which means I'm supposed to be paying attention to when the x-coordinate is slightly negative of b. I'm supposed to be figuring out what the output is getting infinitesimally close to. For votes. So a few people not voting yet, but that's okay. If you're doing this, give yourself 2 points. So your eye should be drawn right here, because this red line is x equal to b minus. It's very, very close to b, but just a little bit negative. Any questions here? Focus is very good. Pretty good? Awesome. Do this one now. Do the limit as x gets close to b from the right. your hands. So I go along this line. I want to go to just a little more than b. And again, don't just copy what I do, make sense of what I'm doing. If it doesn't make sense, just speak up and we'll talk about it until it does. So looking right there, that's an x coordinate of a little more than b. It's a y coordinate of a little more than 1. Therefore, the limit is exactly 1. If you did this, give yourself a point. Please talk to me.
So is the limit exactly 1?
Isn't exactly 1. It's because the word limit literally means, as you are, the way I think of it is like I have this, infinitely powerful microscope. And I zoom in until I can see all of the dots, which is impossible because there's an infinite number. It doesn't matter how close I zoom, there's still more dots, but go with me for a second. So I zoom in until I can see the dot that has an x coordinate of b plus. When I look at that, I see that the y coordinate of that dot is just so very, very close to 1. It's not exactly 1, it's very, very close. And the idea is that once I do that, I think, oh, wait a minute, I can zoom in some more. So I zoom again, I see a whole bunch more dots. Like, oh, I'm even closer now. So now I'm even closer to b from the right, and I'm even closer to 1. Limit means what are you getting infinitely close to? So that's why we write 1. That's not the world's best answer, but that's the general idea. Is that okay? Like 2 points. Anybody else? The microscope thing actually is the best analogy I can think of, where you think you've seen the last dot. You're like, oh, the coordinate's a little more than b, a little more than 1. But if you click multiply by 10 again, suddenly you see more dots, because you just can't stop zooming in. But as you get closer and closer to b from the right, you are getting closer and closer to 1. If you do the same thing up here, you'd get closer and closer to 2. So, anybody else? Okay, keep going. Please show me on your hand what I should write for the blue one. Show me what I write for the blue. You non-voters. I prefer you guess as to not vote at all. So if you're doing this, give yourself 2 points. It doesn't exist. I sometimes get a little lazy. Instead of writing non-existent, I just write D and E, does not exist. Please,
do you want us to use undefined for just like functions and then doesn't exist for like limits, or can you like you all separate it like that?
That's perfect. From a common sense perspective, they mean the same thing. Strictly mathematically speaking, they will always use the word undefined for the value of a function, and for a limit, they'll say non-existent. So, good question, 2 points. There you go. Awesome. Did that answer your question earlier? Cool. So again, look, the left and right limits don't match. Therefore, this is a jump discontinuity. Let's do this one now. Oh, please, please.
So overall, the whole function, or whatever, would it be have jump and removable discontinuities?
Well said. So any function can have any number of discontinuities, all different types of discontinuities. This one has 2 of them. Perfect. Perfect. Jump discontinuity, removable discontinuity. Avery, 2 for Dan.
So if you have discontinuity, does it automatically make it so that the limit doesn't exist?
No. Let's talk about that right now, actually. So if I'm trying to find the limit as x approaches a of this function, automatically I've got to think of left and right. So let's do the left first. So show me on your hand what is the limit of this function as x approaches a from the left. Show me. Limit as x approaches a from the left. So a couple mistakes, let me talk. Here's x equal a. Just a little bit left of a would be right here. In the word. So So I'm looking for the dot that's along that red line. I find it right here. That red dot has an xy coordinate of, let's see, a little less than a, and slightly less than 2, slightly negative of 2. So the limit means as x gets infinitely close to a from the left, the y value, the output's getting infinitely close to simply 2. Questions? Perfect. Do this one, please. Show me on your hand, please. I have a very soothing voice, Drew. No, sorry, Drew, this hang in there and relate to it. I've had that same feeling. So if you're doing this, give yourself 2 points. Cool. I hate the feeling of being in front of a bunch of people and I'm trying to squeeze. Can't stay awake. It's like impossible. Never mind. Moving on. Okay, we good? What's this equal to? Show me on your hand. This one here, purple. Show me on your hand. What's this one equal to? Give yourself 2 more. Perfect. So this is an example of the limit does exist, but there is no value of the function at a. It's not there. So this is a removable discontinuity. Removable occurs when the limit doesn't match the value of the function. So that's removable. So the left and right match, that means there is an overall limit, but the value of the function doesn't match. Question. Okay, definition you need to memorize is this. A function is continuous. Let's get rid of these others for a second. A function is continuous if the overall limit is exactly the same, continuous at a point, if the overall limit is exactly the same the overall limit is exactly the same as the value of the function at that point. So here we saw that at x equal a, that is not true. The limit and the value of the function don't match, so the function is not continuous. If this had been a solid dot, the function would have been continuous at a, because these two would have been the same. So when you're talking about continuity and limits, you're often talking about 3 points is the way I think of it. You have the point in the middle, the point on the left, and the point on the right. If all 3 of them are infinitesimally close to each other, we say the function is continuous at that point. So, question? Oh, please. Huh? No worries. 2 for Allison for asking. Anybody else? Oh, please.
Can you just explain that one more time? I don't think I got that.
This one here.
Yeah, it's about if it's continuous or not.
Gotcha. So when you look, I'll ask, in fact, I'm going to do this, Sarah. I'm going to ask a series of questions. You just answer as best you can. Right or wrong doesn't matter. As you look at this function f at x equal a, what's the value of the function when x is equal to a?
Non-existent.
Non-existent. So would you say that this function is continuous at x equal a or not continuous?
Not continuous.
Not continuous. I can think of that a couple of ways. One would be if I'm trying to draw the function, I go dot, 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 dot. I have to stop. I can't draw a dot. And then I keep going again, so I had to lift my pen to do it. So not continuous.
Right.
Fair? Mathematically, though, what's the limit? We just did it a second ago. As x approaches a from the left.
2.
And what's the limit as x approaches a from the right?
2.
Also 2. So the limit exists. It's equal to x. It's equal to, so the limit is this one. As x gets close to a, the y value is getting close to 2. But the value of the function precisely at a is not known. So because those two aren't the same, that's what causes the discontinuity. If this had been equal to 2, this would have been a solid dot. And it would have been continuous at x equal a. Was that your question?
Yeah. For some reason, in my mind, I just thought that if the limit was approaching what the whole was, then it's like continuous. And I was like, wait, what?
Oh, no. Good comment. So that's why I always do this. When you're thinking of continuity, you've got to think of 3 things. The value of the function in the middle, that's this, f of a. You've got to think of the left-hand limit. This is left for you, not me. That's the limit as x approaches a from the left. You've got to think of the right-hand limit. So you think of all 3 of them, this one, and this one. If all 3 are the same, then the function will be continuous. Does that make sense? So think of it this way, Sarah. 2 more for Sarah. I wrote the definition of continuity like so. Another way you can write the definition, which is just as correct, is to write this. Continuous if the limit as x approaches a from the left is exactly the same as the value of the function at a, which is exactly the same as the limit as x approaches a from the right. So that matches up with my little 3-point idea. So either definition is fine, because the only way for this to even exist is if these 2 are the same anyway. So when I see this one, I have to be thinking left and right. So you have to have all 3. Does that help?
Yeah.
Very good. Anybody else? Perfect. Give me a second to write that down if you need to. So think of a continuous either this way or this way. They mean the same thing. So perfect. Okay. Next thing I want you to do is just a real quick check to make sure that you're feeling good about this. So I'm going to give you this sheet. This is just for in-class practice. I want you to do this side very quickly. Last period took about 3 minutes, once this makes sense. So do this. Feel free to work together. But again, you should always try and do it yourself first. Like, I really believe that you will find yourself understanding things far better if you understand it alone and with help as necessary, not as like your first option. We'll do the back a little bit later today. So I'm just walk the room as you're doing it. If you want to stop me and ask me anything, just stop me. So. The desks always push forward. Wow, that was lucky. Wish I could say I counted that one, but I did not. Did the front work out perfectly too? That's like a miracle, because I do not have the patience to count, so I just go like that. So, good work. Working, if a thought pops, you can just stop me and it's no big deal. So. is the question, just to clarify. So he's looking here, and he says, okay, as x gets close to 0 from the negative side, his eye is drawn right here. And this graph has way too big of circles. It's really infinitely close. So that means the output value is also really, really close to 0. As I come close on the right side, I'm looking here. So that's also infinitely close to 0. Question for the whole room. I want you to vote with your hand. We'll pay. Yeah, let's vote. I don't care if you're right or wrong. I just want you voting. When I go to answer this, should I look? So you've got 3 options here. Option 1 is I just look right here. I don't look anywhere else. Option 2 is I just look at the graph to answer this one. And option 3 is I look at both. What's the best option? Like really, I've answered this, I've answered this. Is my best option to just look here? That's option 1. Best option to look up here, or best option to look at both? Show me in your hands. Okay, so hands down, let me explain. In my opinion, and everybody gets 2 for voting, mark them down. In my opinion, your best option is just look right here. Because the only way to find the overall limit is to compare the left and right limits. So once I've found the left and right limits, I don't want to go up here anymore. I just look here. Because these 2 are both 0, this has to be 0. So I don't want to look up that anymore. And you can, but no need. You've already figured that out. Question. Does that answer your question? This dot is a different question. I look up there if I'm trying to find f of 0. So if I want to find out the value of the function when the x-coordinate is 0, that's when I have to look up here. But for limit, I don't look there at all. Question? Please.
So the second graph for 2 and 3, and then 4, what would the answer be?
So 2, let's just check the room. I think people have gotten this far. Just show me on your hand what you're getting here for 2. Show me. So we're getting close to 0 from the left-hand side, which means we should be looking right here. That means the limit should be infinitesimally close to 0. If you had this on your paper, raise your hand, please. Give yourself 2. 0 plus means I want to look here. That's drawn incorrectly. There should be a connecting line there. It's just a typo, printing error. That point, x is really close to 0 from the right, but the y value, the f of x, is getting really, really close to, show me in your hands. Pretty nice, cool. Question? So this one is non-existent. I just look at the fact that those 2 don't match. That's your question, Elijah. 2 points. Any other questions on these first 4 on either side? Looking at the answers. Cool. So here, just say it aloud. What's the answer to 5, please? Just say it. Is it class? Louder?
3.
Louder?
3.
That's better. 6?
3.
7?
3.
Question? Please, Cass.
So by definition, that would be continuous.
Oh. Again, I'm going to ask you questions and pay you some points to just talk with me. Is that okay? Cool. So as you look at this picture, and you go to x equal 2, don't look at this at all. tell me as you look up here, would you say that the function is continuous or not continuous at 2? Not. Does that make sense? Because there isn't a point at 2 or missing the point. That's because per the definition, the limit exists for sure. But the limit does not equal f of 2 because f of 2 is undefined. So the limit can exist. It does. The limit is 3. But because the limit doesn't match the value of the function, it's a removable discontinuity. So I don't know if I answered your question.
You did. Just like continuous, I guess. I'm still confused about like continuous, you know, the definition you gave us.
So 2 different ways to think of continuous. One is common sense.
Yeah.
As I draw the dots, I get to a place where I have to stop drawing dots and move. So that's not continuous. Mathematically, the definition says that to be continuous, the value of the limit must equal the value of the function. So the value of this limit is 3. But at exactly x equal 2, there is no function value. So these two are not the same. I don't know if I helped though.
Yeah.
Okay. Good question. What's the answer to the other column, number 5? Say it, please. Last? 2. Is it 2?
Yeah.
Okay, making sure. Yeah, we're good. 6? 2. 7? 2. Answer this, please. This means yes, this means no. Is the function continuous at x equal 3? Yes, no. Show me. Is this function continuous at x equal 3? Yes, no. Vote. Come on. This function, this is back to Cass's question. Is function continuous? Yes, no. So everyone give yourself a point for voting. Not continuous. Watch how I draw it. I do dots along here. I must pick up my pen, come down here to draw a dot, pick up my pen again, come back up here to draw a dot. So at x equal 3, the function is not continuous. Mathematically, the reason why is the following. Show me on your hand what f of 3 is equal to. Show me on your hand what f of 3 is equal to. Nice. That's 1. So the limit, give yourself a point, please, and the value of the function don't match. So because the limit and the value of the function are different, not continuous. It's a removable discontinuity because the limits match, but the function value and the overall limit do not match. Hence, removable discontinuity. Right here. Question. Outstanding. Let's just read the last 2 real quick. I think we've actually done them. What's this 8? Say it. So this one's undefined. Number 9? 3. Questions? Okay, let's go here. F of 2. 0. F of 3. 1. Perfect. Okay, last thing today. First of all, let me explain a bit about my philosophy. Okay, when I prepare for class, I try to prepare more than I try to make a target of how far I think I want to get, but it is not uncommon, just due to the fact that I refuse, like I really try hard to never go faster than you can absorb. And so if the discussion is really good, and I felt like today was really, really good. You're asking about the right things, you're trying to make sense of it, you're trying to understand, not just copy. So we have a really good discussion, and because of that, we don't get quite as far as I had planned. I try really hard to never like hand you a homework assignment where the final words as you walk out the door are, well, we've done about half of it, I think you can figure out the rest. Or the final words are, well, let's hurry and do one example and hopefully that will help you answer half of the homework questions. Okay, I hate that feeling. So I'm giving you a packet. The homework assignment tonight is to only do the problems in the packet that deal with the graphical and piecewise functions. We have time to go over the piecewise still. They come pretty fast now. We didn't have time to talk about the other ones. So do not do the other problems, just the graphical and piecewise in the packet. Another thing, the answers are in the back. Never use the answers to help you figure out the problem. If you do that, you run the high risk of teaching yourself math that is wrong. I'm dead serious. I've seen it happen to lots and lots of people. They'll try to use the answer to figure out how to answer the question, and all that happens is they teach themselves incorrectly and get more mixed up. The purpose of the answer is to verify that you're using what we learned in class. If you use the concepts we learned in class, then you verify that you're doing it right. We got 3 minutes to talk about piecewise. It goes pretty fast. So look on the back side of that other sheet. And just look at the first 4 for a minute. Okay? Piecewise is really simple. Focus hard. Piecewise is really simple. Okay. Number one thing to remember is we're not doing something new here. The concept is exactly the same. It's just how you apply the concept is slightly different. It's still exactly the same concept. We're supposed to find the limit as x approaches 3 from the right. So look up here and I say, okay, here's my formula for the function now. So instead of a graph to find all the outputs, I have formulas. Piecewise just means you have more than one formula. The top formula gets used if the input is between 0 and 3. The middle one gets used if the input is exactly 3. The bottom one gets used if the input is greater than 3. Simple. So I'm trying to find the limit as x is approaching 3 from the right. My brain is saying, okay, so I'm bigger than 3, and I want to find what the output gets really, really close to. So I look up here and say, just say it out loud, please. So I use the top, middle, or bottom? Bottom. Think, okay, 2 times 3 is 6. 6 plus 1 is 7. Well, it was a little bigger than 3, so it'll be a little bigger than 7, but it's like I was saying to Elijah, it's infinitesimally close to 3. So that output's getting infinitesimally close to 7. Even though it's a little bigger, it's still infinitesimally close to 7. We didn't want to talk about that. Okay, let's keep going. X is getting close to 3 from the left, and a little bit negative of 3. So should I be thinking top, middle, or bottom? Say it. Try again. Top, middle, or bottom? Top. We're a little bit less than 3. So that's this one. So I think, okay, 3 squared is 9. 9 minus 2 is 7. So if x is getting really, really close to 3, it's going to get really, really close to 7. It won't be exactly 7, but it will be infinitesimally close. We want to talk about those two. Okay, this one. Just say it out loud, please. Actually, vote. Do I look up here? That's option 1. Or do I look here, option 2, to answer 3? Show me your hands. Where do I look? Do I look up here to answer? That's option 1. Do I look here? That's option 2. Give yourself 2 points. Since these two match, this one matches. Questions? Okay, to answer this one, they use top, middle, or bottom. Say it.
Middle.
Louder?
Middle.
Middle. So when x is 3, y is 2. What kind of discontinuity is it? Removable. The limits match, but the limit doesn't match the value of the function. So it has a removable discontinuity. It actually looks something like this one that we were playing with a minute ago, where the limit has 2 values that are the same, but the value of the function is different. Stay with me, we've got a minute still maybe. Questions here? Okay. Just look at the next one real quick. So, greater than 1. So we've got to use the bottom formula. Anyway, I think you're okay.